was really cool.
I
had
told you.
no idea that was happening.
Yeah, I was trying to do something epic as much as I can.
Yeah, that was awesome. I'm glad it was recorded.
Yeah. What a nice entrance. I think
Thanks.
it's working perfect.
Yeah. Okay, so, yeah. Bonjour Paris. Ça va bien? I think that's a yes. Cool. So, solid patterns. Yeah. Before we get to why I'm talking about solid patterns in a React conference, I feel a little bit bad about saying who am I after that introduction. I'll never top that. I think I'll just replay it again and again everywhere I go. But essentially, like, my name is Atila, and I work at a place called Crab Nebula. I am part of the Solid DX team, and I'm also a Google developer expert for web technologies. You can, because like naming things are hard, and I switch usernames every now and then. I put like some shortcuts, so atila.io/whatever social network you can find, and you can rant at me about stuff that I say. But yeah, like, why am I comparing frameworks? Like, essentially because the work we do at Crab Nebula, we work a lot with this framework called Tauri. How many people heard about Tauri? Awesome, a lot of hands, that's cool. So the Tauri, for the ones who never heard about it, it's a framework for building like hybrid applications. Basically, you can build for iOS, Linux, Android, Mac OS, and everything else with web technology. So it's a Rust framework that brings the web view, and then you can switch whatever framework you want. So I play around a lot with different frameworks. I'm a little bit biased. My favorite one, it's in my slide already, and that's what my talk is about. But yeah. But what I'm here to talk about fine-grained reactivity first. And I think the biggest question is, because I'm in a React conference and React doesn't do fine-grained reactivity, is why? Seriously, why? Does anybody has like a word to shout? Anybody has a clue? Like, why am I talking about fine-grained reactivity here? Yeah, so that's a hint. It's not because of performance. And that's the thing to me that I feel that's a little bit of a shortcoming of all of us that advocate about fine-grained reactivity is that, yeah, the performance benefits are great and they're good for everybody, but they're not the main reason why you should migrate your stuff or why you should adopt a different mental model. And to do that, I think there are like 3 ways, generally speaking, that's like a much, much deeper topic that a lot of way smarter people than I try to explain. I'll do that in a single slide because that's not even the topic of this talk. But yeah, essentially when you're handling data, there are basically 3 ways to do that in a web, or the common ways. One is like pulling data, the other one is pushing data, and then there's a third one that's push then pull data. Let's see how they work. Essentially, you have the data, and you have a component. What happens with pull is that your component is there, living its life or whatever, and then, OK, you got an update, you got an update, you got an update, and then it has an update, and then you get the update, and then everything re-renders, and then everything updates, and it's awesome. And then you have another one, which is data, and then there's new data, and boof, it just shoves it down into your component. And the third one would be a push then pull, where the data basically say, look, I have an update. And then component says, oh, please, I love that. And then it goes and pulls the data. So if my little theatrics are not good, are not explanation enough, just to be clear, the pull data is what you're used to in React with useState, where on every update you try to find if the state has changed or not. And when it has, there's no way of tracking what has changed or not, and then you just destroy the current state and build it again. And then the push then pull is what we do essentially with signals and why we call it fine-grained reactivity, because then the data can essentially let your rendering to know, look, I have an update. and then things can trigger as effects and then update only the parts that changed, because if the data can tell it changed, it can say to everything that depends on it that it needs to update. And that's a big summary. And like, essentially speaking, for us in the mental model, when React came out, we talked a lot about like components being a function of the state and stuff like that, and coupling everything. What we're doing now is going back, like splitting them. So we have the component, which is basically kind of an artificial boundary just to make it easier for us to reason about our code base. But essentially, the data and the rendering parts are not coupled in a way. And that's in a very like quick nutshell what signals are for, and why I think fine-grained reactivity is important. And it becomes even more important for React developers, because a lot of your libraries that you consume, so you maybe don't deal with fine-grained reactivity on your day-to-day basis, but the libraries you're using, they do, because they cannot trigger a bunch of re-renders on your stuff based on the stuff that you are updating. So that's why a bunch of libraries, like a bunch of great libraries, try to like basically juggle between having the updates but not changing too much. In the same way, not taking the state out of synchronicity. So basically, the state that they have in inside the library needs to go back into what is the state. So that's a lot of the pain that many library authors deal with, and that's why I think it's important to talk a little bit about fine-grained reactivity in a React conference. Also, because we don't live in a bubble. So although most of you probably work with React, and not very long ago, everybody was doing coarse reactivity, but what happened is that a lot of frameworks, basically all frameworks except React, are adopting some different degree of fine-grained reactivity. They're actually, like at this point, they're much closer to the fine side, though my line's a little bit short, so that's why. And like, what's the talk without memes? So basically, the thing is, that's the point. Like we do, like with signals, it allows you to be like more surgical on the updates, and then you don't need to deal with a bunch of like headaches that you deal with when you have like a lot of eager and excessive re-rendering on apps. So basically, things you need to forget or don't forget, or like effects you want to use, or I don't know, dependencies and stuff like that, you don't need to deal that much. But yeah, so let's talk a little bit about how this actually works. So this is a solid code. It looks a lot like React. Like with these contrived examples, you need to squint a little bit and see that it's not use state, you're creating a signal. But other than that, it's pretty much the same. And let's do a little exercise. I'm going to render this button. And think about for a second, what do you think would happen if I click on this button, considering that you have that count and you're triggering an on-click on that count? What's going to happen in a fine-grained reactivity is that I click the button, and only that count updates. Because that's essentially what's happening. You're going to trigger an update on that signal. The signal is going to let know everybody that depends on that signal, look, I have new data, and that's why that's a function call. And then it's always going to bring the up-to-date result. So memo never again. If you go to fine-grained reactivity, you're free of memo. That's also like a big misconception that we kind of guide you towards for like trying to be like direct with our language and stuff. But actually, there are use cases for memo, because memo is a very valid pattern in terms of avoiding a lot of work, and especially when it's expensive. So let's have a look at this code right now. And basically what's happening is I'm creating a new state, a piece of state that's derived from a first one. So if we look here, this is basically how in Solid, we create a state that uses another one. We call it a derived signal. And we are deriving the value of a super count from count multiplied by something. This is horrible code. You're probably thinking like, why would I do that? But essentially, it's just a very contrived example for you to see this kind of side effects. So yeah, let's have a little look on a demo about how this works. So essentially, I have the same thing. I did a few like changes here and there just to make easier for you to view. So essentially what's happening is on every time I call, because this derived state is essentially a function, every time I call, like all of them call and all of them have another random number, right? But in a case like this, that would be very unlikely what you want. So a solution that you could do in this is basically memoize. So then that's going to say that you're only going to update this once every time that signals which I depend on are going to do. And you notice that that's another like little trade-off that a lot of people get excited about, because I've been a React developer for a lot of some good years, and the dependency array stuff was always annoying. And the fact that you don't need that with like the observable pattern, which is what powers the fine-grained reactivity, is because the state can actually trigger everybody that depends on it, so you don't need to declare it in 9.5 out of 10 cases. So yeah, basically that's how memo works. So then you can memoize this, and what I meant that this is like terrible code is that basically you can just use a good old variable. So you could just store this value in a variable, and then you don't need to memo, and then it works pretty much the same way. Or you could have another state or something like that. And basically, like you wouldn't really. So memo is when you're doing fine-grained reactivity, memo is a valid pattern, but it's a pattern that you very rarely need to do. And that's the thing that appealed to me the most when looking at about how fine-grained reactivity behaves and how it works, because I think that it's a much more accurate mental model of how the UIs behave, or how I reason. How I reason about the UI changing. So yeah, but that's pretty cool and all. Like we all come here in the slides and we show like these little code snippets that don't look like reality. And okay, so what happens if I have like complex types like arrays and objects and stuff like that? For example, I have something like this. How do I create a signal? How do I do fine-grained reactivity like that, Morris? So the thing is, basically what you want is this. Every signal, every like key of the object is an independent signal. And then you can do fine-grained reactivity. Can you imagine writing that, though? It's terrible, right? That's horrible DX. So basically, you can create a store. And a store is a way for us to do this reactivity with this type, so with these complex types. So basically what it does under the hood, it uses some JavaScript primitives to be able to create, abstract away from you all the signals being created and reacting. And basically that's how it works. So this is like in the native library, all of them, this is what I'm showing, like the codes are in SolidJS, because that's what I'm more comfortable with, but every framework that does fine-grained reactivity has some version of that. Like Vue has shallow refs, Svelte runes, I don't know, have big runes, I don't know, something like, I don't know. But yeah, again, this is great, but what about if I do some deep nesting? Because essentially our code looks more like this. And then we have a store that has this object, and then the object has keys, and then we have an array, and we want to be able to do this fine-grained reactivity, even if we go like deep down a bunch of levels, right? So that's why we have something called produce. Some of you might be familiar with immer, as in the immer syntax, like if you played around it before. Have you? Like, I didn't. Yeah. Okay. Cool. Better than me. Okay. So I didn't really use immer, but this is a similar syntax to it. And essentially, what it does is allow you to do this fine-grained reactivity on deep nested objects. So basically, you're not going to mutate the whole object. It goes doing all the shallow diffing for you, and only basically mutates what's there, what you actually want to change. So in this case, I can push an array, I can push to my list array, I can change the name, and age, for example, is not going to change. If something depends on book or pen, is not going to trigger any sort of re-rendering. So yeah, basically that's produced for you. Great, but how about like those big changes where the whole object kind of changes and I cannot predict exactly the way I'm going to write a bunch of products and conditionals and crap like that? So let's take this example. I have my to-do app because we all build to-do apps, right? I love to-do apps. So let's say I want to do some time traveling with my to-dos because like yesterday grocery list was killer. And essentially I want to like navigate in time. So now I can do this reconcile. And essentially this is going to trigger a shallow comparison on everything inside my store and just update what's absolutely necessary. So I can pass an object as long as they have the same shape. Reconcile is going under the hood, pick the current state from this set store, and do the shallow diffing and bring it back to me as I want it. So yeah, that's basically how we can do the whole like shallow we can maintain reactivity and use all the benefits that we can have with fine-grained reactivity and have the same kind of comfort you would have if you just went nuke on your UI and started over again. So the things about that is that it just triggers the exact amount of code that you need to trigger. So that's good for your mental health most of the cases. And because it's only triggering what needs to be changed, it doesn't remove the stuff and adds back to the DOM, as we know. That's what causes performance bottlenecks in our stuff. This also leads to good performance. But emphasis on the lead. It's not gonna, it shouldn't, like, you can write very performant code on any framework nowadays. But it is a good default as a consequence of this mental model. So to recap, fine-grained reactivity is about the surgical changes instead of re-rendering. And that's awesome for UIs. But right now, everything is full stack. Everything is isomorphic. You have Next.js, Remix, Nuxt, we have SvelteKit, and so on. So how do we do that? So to do that, for Solid, we have Solid Beta, which I know it's a bummer to talk about. I forgot to put the notes. Sorry. So yeah. Okay. He wants me to add stuff right now in the talk. So apparently we're releasing the Solid Start 1.0, which is the full stack framework for Solid. And so yeah, Ryan Carniato wanted to make sure I thanked everybody that worked. We had over 200 contributors for it. And this is the release candidate. So basically, right now, it's ready to be used on production apps. You can just do all of this. You can create a new Solid app. And you have Solid Start, which is the full stack framework for SolidJS and fine-grained reactivity. And yeah, but there's this RC there, right? There's a catch. So what the heck does that mean? Basically, like, we have different stages of creating new frameworks and libraries. So basically, when it's alpha stage, it means we're defining the APIs. And then on beta, we are testing those APIs. On RC, it means the APIs are done and they're being tested, and we are, sorry for the pun, solid. And we're now doing the docs, we're doing some bug fixes, and that's supposed to be like a very short period of time. And then once that happens, we are stable and life goes on. So this has been like Solid Start has been in the makings for a long time. There was a bout of rethinking and stuff like that. And it is a very meta framework. There was a lot of like thinking process around that. As anybody, who here is familiar with Solid Start at this point? Yeah, okay, all my friends here, yeah, and awesome, great. So yeah, so let's talk about what it is. Basically, a Solid Start is completely decoupled. Like the talk, like Anthony's talk in the beginning resonates a lot with me in terms of, yeah, we're just going to pick everything that the community has to offer and try to build our stuff on top of it. So basically, we have this, this library called Vinci, which is putting together Vite and Nitro. Like, if you remember what Anthony talked about Nitro, it brings some compiler stuff out of it. Nitro itself also has a little bit of Vinci involved, and it provides the server runtime with a bunch of like nice libraries and helpers and stuff like that. What Vinci does is encapsulate all this to provide some nice defaults and some ease of configuration for us to create frameworks on. It's not something exclusive for Solid Start. It's completely agnostic. As a matter of fact, there's somebody that already created a React framework using Vinci. And then once that happens for any full stack app, like arguably the most important part for this isomorphic part is serializing, because when you're crossing from the server to the client, you need to serialize your data in a way it can traffic through the wire. So we have this other library, which again has nothing to do with Solid Start. It's used by Solid Start, called Ceroval, which is super strong, empowers some nice features we're going to talk in a minute. And then router. And the router needs to be compatible with whatever is happening in the backend and with Nitro and stuff like that. So because it's all decoupled, you can come and plug in whatever router you want. If you want to use 10-stack router and things like that, technically you can. The problem is, and it's a big technically, is that there's no other router that has all the integrations that Vinci would need to connect the backend with the front end. So the easiest one right now is Solid Router, but nothing is stopping anyone to create integrations for any other router. And once that's happening, you're on the client side, and then you have a Solid app. Cool? Yeah, and that's what builds Solid Start, essentially. And that's essentially what we are supposed to call a meta framework. It's when you bring a bunch of different little frameworks or little tools put together and create something that gives you more capability and functionalities. Okay, but that's all good and boring. Let's talk about the features that we have, because there's some pretty nice features, and it's a little bit, to me, it's a little bit impressive that in RC already have all of them. The first one, and the most important one, is to say goodbye to requests waterfalls. Solid Router is very strongly parallelized, which means every request you're firing is gonna go, they fire super eagerly, and you're not gonna have any kind of chain request. That facilitates a lot of performance and unlocks some of the nicest superpowers that Solid Start has. So yeah, resource fetching is by default. And this is actually a code that I took out of the Solid docs, and just so you see, we have the same kind of problem with a bunch of providers and stuff like that. It's all very familiar, right? I wrote React apps exactly like that as well. But what I wanted to show you is this part, where we have the router, and we're passing the root as an attribute, and everything inside the root is wrapped in a suspense. And you see right down there, we have the file routes. The file routes is a special component in Solid Start that's basically just scanning a certain directory that you define from configuration, where your routes live, and converts it into a file configuration object that the Solid Router can understand. So basically, everything that is there is going to be server-side rendered and rendered as a child of that root. So around the suspense. That's how we can get every request to be parallelized, because every time you trigger a navigation, it's held by a suspense, and you can fire the request. So this is how data loading essentially works. Because everything's in parallel and you're navigating eagerly, we have this part where we define, okay, so you only show my component if you have the data, and you have this little fallback that you can pass. Basically, like same syntax as you have with a bunch of React APIs. And then the create async is basically you're passing your data fetching stuff. And you reach this route right when you click. Request was fired before, but then you have that little little time where data is still coming. On top of that, if that's not what you want, you can just pass an object saying, okay, defer the stream, so basically wait for my data before rendering this stuff for me. That's specifically useful for SEO stuff and things like that, but essentially you want it to be snappy anyway. And as a matter of fact, if you want this route to actually preload and start firing, start actually as soon as possible, what you need to do is just export a route and define a load function for that route. That means that the request is going to fire as early as possible, and then you still need to account for not having data, because there's always a chance your network lags or your server lags or something lags. But yeah, very unlikely you see it. Yeah, talking about that, there's also a lot of, like, you can also control the cache part. So the cache part, the cache function is essentially a wrapper that returns the same function, but then you define a key, and that key over there is what's going to dictate, is going to help us deduplicate that request. Talking about that, turning a data loading from running on both sides to a server is like one line. And like what Vinci is going to do is essentially do the whole tree shaking and making sure this thing doesn't end up in your client bundle, yada, yada. You're used to that with Next.js as well. So pretty much the same thing. And then again, the validate. This is for Solid to know how to deduplicate stuff, so you can handle that the way you want. But essentially, every request is ideally have the same caching, because then you can avoid firing the same request twice. And that's essentially like for React stuff. You're familiar with that, with doing some prototype tainting on the fetch object. We decided to do it this way. So basically, you define a string, and then we don't mess up with your JavaScript specifications. And talking about deduplication, we actually have deduplication in 2 spots, which is a little bit different, but nice. Think about this. You have this third-party API, and then you have 3 server functions. And all these 3 server functions are connected through the cache. So essentially, it's the same request. So the cache is going to make sure that you only fire 1 request, and then you get it back. Once that server function receives, it's going to have to serialize that. So all of them are connected to the serialization, which is Serial in this case. And what Serial is going to do is store that serialization part into, I don't want to say those words, but like global store or something like that. It's essentially going to hold on the artifact and say, look, I already serialized this. I'm not doing that again. And that's going to save you a little bit more. If you have like different requests returning the same object, you only serialize it once. Once that is reached the RPC layer and done to your client. We also have server actions, which are like way different than what you're used to, right? Which with server actions, essentially you wrap it into an action, and basically that's it. And you get the progressive enhancement with defining the form action. You pass the function, and then you pass the method post. And this is going to handle the whole thing for you. And there's one thing that, to the best of my knowledge, is a big game changer. Is that, again, you can do this. Server actions are server functions. We have single flight requests. Are you all familiar with this term, or is it new for you too? OK, so it was new for me. The first time I talked, Ryan mentioned this in Solid Start. What we have essentially is you have this server action, and this server action is going to return a redirect. What usually happens, and what the mental model we're used to, is that the redirect, we return to the client and say, OK, go to this other route. And then the client's going to go to the other route and fire the request and gets the data and then renders the route, right? What this is going to do is it's going to return the new page data with the response, with the redirect. So you throw the redirect, and in the same flight, it comes back already with the data that you're going to tell the browser needs. And again, with those like solid router methods, you can have like the JSON method, the reload method, the redirect method, and you can control the status, you can control the cache, you can control whatever you want manually, or SolidStar is going to do that by default and just flush the cache on the new page render and behave like heuristically as you would expect, unless you have a special case. If you want to know more, there's a bunch more. We just released the new docs for this Solid Start, and it was like a lot of work. I need to thank like I work with this, and I need to thank Daniel Afonso, Sarah Gerard, and Burke also. I cannot pronounce his last name. I'm sorry, Burke. I cannot pronounce his last name, but yeah, they did like a 48-hour effort on putting the basic documentation so you can get started. And with that, thank you very much. And you can find me usually on YouTube or X with that little shortcut. Thanks.